All right, good. So this is going to be probably about a 15-minute session or so, talking about how to calibrate stationary wax on the UPenn Zeus 2 using Exact. Um, what I have just done is uh, done a measurement on the calibration plate for the 4 different samples that are there: Lab 6, glassy carbon, silver BN8, and the standard SB1010. What I will do is I will use the Lab 6 to check the calibration, alter the calibration, and then show you how to use that calibration value in Exact to correct the calibration for these 3 other ones. Um, I'll also show you how to change the parameters. Let's say we had done the Lab 6 before measuring the others. Once we have the calibration parameters, it's also possible to change the calibration parameters, and then they will automatically get entered into the header for the next sessions. So the WAXS calibration unit works the same as the SAXS calibration unit of Exact, but it's turned out that there are a number of challenges, including some things I would consider bugs and some things that are very peculiar about how it operates. I don't quite understand how, when I'm trying to work with the programmers to figure out whether these are bugs or just an optimization that's going awry. But in any case, let's quickly take a look at the data before we move on, just to see that the data is good. So I have the data on this second screen here, and let's take a look there. So these are the 4 data sets. This is silver BN8. This is the glassy carbon. This is silver BN8. Sorry, this is Lab 6, glassy carbon, silver BN8, and SB10. And what I'm going to be, the first thing to do here is that it's possible to go in and check what the calibration parameters are by going into the edit. Here again, I right-clicked on this. Let me just make sure here that let's see here, that I'm showing the remote cursor, just to be sure. View monitors, show remote cursor. Okay, good. All right, so the remote cursor should be shown now. So I'm right-clicking on this here, and then I'm editing the first file. I get this up here with a number of parameters in here. Now, the ones I'm looking for is the center 1, center 2. You can see those are 100 and 267. And then I'm looking for the gamma and the delta value. So the delta value is here, -31, and the gamma value is 0. And then the sample distance is 0.16. Let me jump back to the other screen. Now those parameters are here. Let me just correct that. That was 267. So these are preset. The delta and the gamma, I believe, are set at startup in the Xenoxs settings.mac file, and the center, the X center and the Z center, and the distance can be set with this command here. And I think that's familiar. In SpecFE, there was a small GUI to do this. There is no such GUI in XICC, but it can be entered with this command here. Now, the values for delta and gamma are hidden in these 2 variables. And if one wants to correct these, let's say within spec, then one can correct these values here. It's possible that that may need to be updated at every restart of spec, but that's how you can set those parameters. And in the same way, if you don't want to have this here, but you want to control it separately, these are the variables that are written to the header. So this is how you can change those parameters. But of course, and I've done this at some point. Now, of course, what we'll want to do is we'll actually want to check that with a calibrant, and I would recommend using Lab 6 for this. Has some very nice strong lines, and so what we'll do now is try to figure out how to use Exact to to calibrate this. So let's go back into here. We're going to look at Lab 6. So this is this one here. We're going to go into Analyze, and you can see I've actually done a little bit of playing around here. We'll remove these for now. Start more or less afresh. All right, good. And we'll take this one also. All right, good. So we're going to go into the calibration routine here. And we're going to draw in this image here. Now, this brings up something which should be familiar from the transmission, but there's some small differences when we get a little bit further down. So we have the choice of Lab 6 or Silver Bean 8 in this setup here, and we're going to do an automatic selection. In this case here, it does a really good job of finding the measurement. I should say this is the Lab 6 measurement measured for 5 minutes on the system in a configuration, and that here then loading that in, you would expect that to come into here and to show you the values that are in the header here. Unfortunately, this is where there is definitely a bug in Exact. It does not show the pixel, the actual values here, and furthermore, if we just do the one press button here, we'll end up with something which is over here. Let me just do advanced mode. And then here. So what we are seeing here in this curve is the red is the nominal data with the existing calibrations. And we see something that actually looks pretty good. But the optimization or the calibration actually destroys this. Again, I don't know why this is happening. It looks to be something with where it starts off and then tries to optimize it. Anyway, not good at all. But there is a workaround, and that's what I'll show you now. I should say that what happens here is it comes up with a number of, with an improved, or with what's in the black here, point of incidences, the detector rotation, delta and gamma, and then a distance here as well. But since this is clearly a bad result, there's no sense in using that. So to fix that and to actually make it effective, what we're going to do is we're going to go into what the nominal was here, which is actually 5 above this value here, minus 31, 32. And I'll just show you that here in this case, it arrives at basically the same. Now, what I want to do then to the workaround is to go up to a number that is higher than 5 times what I suspect the value would be, and then actually try to run that. Now, what that does is the red you can see does not match the calibration lines because it's clearly not 36. But the value that's found is 31 and actually does begin to look nicer. Now, the bug is not done yet. We actually want to be moving up to a point where that calibration provides a value that is constant under some higher starting values. So right now it's still dropping to 5 degrees below, and up here at 40, it actually starts coming to a value which is not exactly 5 degrees below. So at this point in time, we're insensitive to the starting parameters, and the fit looks really, really nice and compact here. So that's the calibration values. Again, using Exact here, those bugs, the workaround here, and the reason that I'm confident that this is a workable calibration is that we are now independent of the starting parameters. We are letting essentially all of the parameters float freely, and we arrive at numbers here that seem to be consistent. Again, let me go down here, 41 and 40. Good. All right. So So what I see here are now the numbers that make that the best possible fit um, according to the routines here. So I'm going to take those numbers and just jot those down. So 98.1. Let me just drag the other window into here, and maybe I can do it on the fly. Well, probably not. It'll get written over. Well, maybe not. We'll see. So after calibration with lab 6, we get 91.8, 17.0, minus 34.05, 0.27, and we get 0.1559 on that particular image. All right, so that's certainly an answer. And of course, with 5 parameters on this, I would expect that that there could be some variation on the actual solution, but here we go with indeed something that it seems solidly provide a solid maximum. Now, of course, what we wanted to do is we actually wanted to perform the data reduction on these 2D curves. So in this case, we're now going to use the information that we got. I'm going to go into here, drag these 4 over, and then we're going to use the parameters in here. So on the header, the X parameters, and I did forget what they were. Right here. They were 91.8 and 317. So 91.8 and 317. And then the delta was minus 34.0 and the gamma was 0.28. So here, minus 34 point. Yeah, I forget already. And here, 0.27. Let me just check. Minus 34.05. There. And was it 0.027 or minus? So that says, let me just go back here and see 0.27 indeed, and minus 34, fine, and then 1 point, whoops. And finally, let's see where we are with this. Then the distance here. There we go. Oh, I'm in the wrong module. Sorry here. Distance transmitted, distance, here we have it. So there we go. And then we run that. And let's see. That clearly doesn't look right. So let's see, what did I do wrong? Yeah. Oh, that's of course wrong. So if it's in millimeters, then it's 159 millimeters. There we go. And I'm going to do this as batch mode. Did I lose all my files now? No, they're all still there. And then here I go with those with those files. So those are the WAXS, all calibrated according to the Lab 6. Again, if I wanted to change the calibration, I would run these commands here, one, and then I could take the data after that, and those data would then be put into the header. So 91.8, 317, or alternatively, here 91.8, 317, and 59. And then here, this would be 34, 105, and 0.27. Now, as I understand it, the wax position may change. I believe it's A in this measurement here. I suppose it could be B or C as well. I'm not quite sure on how to use that, but one could hardwire these if it turns out that it's always the same position. That would help a little bit. That would get you closer. On the other hand, if you change positions, you'll definitely need to run these at to calibrate when you're running with the different configurations. But that's essentially how to use this. Again, I'm not too happy with these bugs that are in this program, but I'm confident that with these workarounds, that the data that comes out is still correct. So anyway, I will stop this now, and hopefully that will give you enough to work on the calibrations and see how that's done. There was some suggestion by Arena to actually use the silverbionate for calibration. I have no idea how one would do that, so I'm not going to go into that, but you're welcome to play around with it. And if you want to share your experience with that, then that's absolutely fine. So let me stop the video here now, and then save that for you.